So today we'll be discussing about oxymercuration and demercuration, and this is the kind of reaction where you get a second degree alcohol where the OH group is attached to a second degree carbon, and we'll see why that is the case in a while. So let's start with this compound which is represented here as HgOAc twice, where OAc is this particular compound. To just simplify the reaction, we usually write it that way. And as we know that a double bond acts as a nucleophile, this nucleophile will go and attack to Hg, which will just kick off the electron from this bond to oxygen, and this group will leave. And this will just look like this, with Hg bonded to the carbon. And now, immediately after it has bonded to this carbon, it will bond to this carbon as well. And please note that it has bonded to this primary carbon before it has bonded to a secondary carbon, because primary carbon cations are really unstable. So it will just attach to this carbocation, then that one. And also that primary carbon cations are quite stable and they cannot hold on to the charge. So this, even though these are positive, this one will be more partially positive, because carbocation couldn't hold the charge on that molecule. So even though these are partially positive, this one is going to be more partially positive than this one. So if we add in water to this compound, what will happen is it will attack this one before attacking that one, because this is more positive and it has more attractive force than this bond. So what we'll get is, oh my god, this is so messy. Let me do this. So since this is more positive, this is positive, but this is slightly more than that one. So here is our water molecule with its lone pairs of electrons. This will go attack onto this carbon, and then it will form something like this with its HgOAc group. And then here is the water molecule attached. Now we'll take another water molecule, which will remove this hydrogen, which is unstable. Because it has a positive charge, it will easily remove this hydrogen, and what will be formed is this compound. This OH will be gone onto this carbon because it gives us its and now this is the compounds that we formed. And also we have this compound with oxygen having plus charge, but we're not going to be worrying about that anymore. That is not going to help us in the reaction. But now to remove this particular group out of the reaction, we'll just add NaHB4, and this kind of this reaction with NaHB4 would require a higher chemistry knowledge, which I don't really have at this stage. So I'm just going to tell you that with this reaction, this group is going to be removed, and actually this would be replaced by an H molecule. So this particular group will be removed, and then we'll just add H to it. So after reacting it with NaHbr4, what will end up is this kind of compound. This would look like this, and since we don't represent it, this is our true 2-propanol, and that is the reaction.